Okay, so what we're looking at here is a left-hand rotation magneto and the impulse coupling that's normally mounted on it. Okay, so these are the pawls on the impulse coupling. This is the impulse coupling shell. This is the magneto shaft, and there's a key, woodruff key mounted on the magneto shaft which engages with a keyway in the hub of the impulse coupling. Okay, so because this is a left-hand rotation magneto, it's left hand is viewed from the engine, so this shaft would be rotating anti-clockwise and will be mounted on the magneto shaft like that. And this here is the stop pin, and you can just see the end of the latching end of the pawl. At low engine speeds it will actually strike that stop pin. Okay, that's normal. Now, this impulse coupling was removed from a magneto for overhaul, so in actual fact this coupling would have passed a 500 hour inspection. There's very little wrong with it. So there's two things that we're checking for here. We use the T150 rivet gauge, and also we use feeler gauges, or you can use a 0.14mm or 0.14 inch drill bit to check the gap between the pawl plate and the back plate. The 0.14 inch feeler gauge must not fit in there, which it doesn't in that case. Okay, the other thing you're checking for is rivet wear, the pawl rivet wear. So the gauge is used to see if there's any margin between the edge of the rivet gauge and the edge of the pawl plate. If there's any margin there, it has to be removed from service. That means the rivet wear is too great. Now the problem with that is that if you look at the latching end of the pawl plate, you can see where that hits the stop pin, and that's normal. There will be some wear there. Where there shouldn't be any wear, and where it will be a warning sign, is if you see wear on the side of the heel end of the pawl plate here. If there's excessive wear on this rivet here, it will allow this end of the pawl to move out to the outside of the impulse coupling, and that brings with it the risk that it will hit the stop pin. Under normal operation, once the engine has been started and it gets up to normal speed, centrifugal force forces out these pawls, and neither the latching end nor the heel end will contact the stop pin. But if you have excessive wear here, what will happen is this end will get pushed out, and if it tips off this stop pin while the engine is at cruise RPM, for example, the contact with the stop pin will then force the latching end out, and the next time it comes around and contacts the stop pin, there will be a catastrophic failure. The whole coupling will explode basically and shed metal into the accessory case of the engine, and that will be a complete engine failure at that point. In a single engine aircraft, you'll be looking for a field in a hurry. Okay.